Hi, welcome back again to the same CRE class. Okay, the topic is variable volume system. Variable volume system. If I say variable volume system, a new term comes, epsilon, the expansion factor. What is epsilon? More about this is a discussion about this topic. Okay, yeah. Variable volume reactors. In variable volume reactors, there are constant, here, batch system. It is again subdivided into batch system and flow system. Batch system and flow system. Okay. So batch system, what are these batch? Variable but batch. Okay. So in this, I can take one example as semi-batch reactor. What are these semi-batch reactors? Semi-batch reactors. Now here, suppose I have a reaction A plus B gives R. Here, one reactant will be in batch mode. A is in batch mode. It is taken in the reaction vessel. It is in batch mode. Okay. And B will be allowed to pass continuously. Okay. So, semi-batch, one reactant in batch mode and the other reactant is in continuous mode. This is a semi-batch reactor. So, one example for a variable volume system and which is operating in a batch mode. And the other one is where what happens to number of moles may vary. Number of moles which are taken initially will not be same when I get the final initial case and final case, the number of moles will be different. This can happen in a CSTR or a PFR also. If number of moles are varying, that also comes under variable volume variable volume system. Okay. Yeah, but in a batch, the reaction is carried out in a batch reactor. But moles are varying. Okay. Yes. Flow system. One example I can take is a gas cylinder. What happens in a gas cylinder? Gas will be continuously coming out. So, continuous flow is there. And what is happening inside the cylinder? The volume is getting varied. So, this is one example for flow system, but volume keeps varying there. Okay. Second one, a fluidized bed. You know what's a fluidized bed? Fluidized bed is one in which the solids are, the solids are actually packed here. If it is just packed, we call packed column. When the reactant enters in, these go to fluidized state. Okay, so the volume here varies with the inlet given to the reactant stream. Okay, so this is one example for a variable volume flow system. Okay. Now, next is how to get the stoichiometry. What happens? See, in V was equal to V naught for constant volume systems. Constant volume systems. What is this V and V naught? V naught is liter per second. Okay, it's a volumetric flow rate, and V is the volume of reactor. Volume of reaction mixture. V is the volume of reaction mixture actually, not when I say V, volume of reactor, it means volume of the reaction mixture. Okay. So V was equal to V naught for constant volume systems. Now V is equal to what? For variable volume reactors. Can you see? Yeah. Variable volume reactor. This is a topic what we'll be studying now. Yes. Okay. Yes. Start going. For that, let us have a recap of what is compressibility factor. Compressibility factor. What you have studied in your thermodynamics class. Compressibility factor denoted by letter Z. This compressibility factor is used for real gases. Equation of state for real gases. See, I know Z, what is Z now? Z is equal to PV real by PV ideal. This is how we write. And what is PV real? PV real I will written as such. What is PV ideal? PV ideal is from Raoult's law. For ideal gases, how do we get PV? By Raoult's law. And what is that? PV is equal to nRT. RT. Okay. So now what will be PV real? PV real will be Z nRT. PV real will be equal to Z nRT. I take this as a basis for developing or for explaining stoichiometry of variable volume batch system. Volume batch system. Or the other way of framing this question is to prove here I am proving to prove V is equal to V naught into 1 plus epsilon A xc. Is what? The different ways of framing the questions for the same concept. Okay. So let me take the same equation now. PV is equal to Z N R T. Okay. This is at, suppose at some temperature T. Okay. The same equation at T naught can be written as V naught Z T naught N T naught R into T naught. This I call it as at temperature T. Z I have retained okay, I have used Z naught in my copy, so let me use Z naught only. I use Z naught in my copy, okay. So let me use Z naught only. Now what I do, I divide equation 1 divided by equation 2. And I'll P naught V naught equal to Z naught and T naught are T naught. So 1 divided by 2 will 1 divided by 2 to find V. Okay. So now V will be V naught into Z by Z naught, T by T naught, P naught by P, and NT by NT naught. Okay. So this is a very important term, NT by NT naught. Okay. So that's a very important term. Okay. So now what is this NT by NT naught? How do I find this NT by NT naught? Okay. So that is what I will start with next. Let me rub this. It's just a recap of the previous derivation what you had done. What did we get FT as? FT as FT naught plus delta into FA naught into XA. Delta into FA naught into XA. This is just a recap of the equation what from your previous derivation. Okay. So, but what is F? F is equal to CA into V. Okay, and this CA is written as MA by capital V, volume of the reactor, into V. So what I'll now do, I'll just I'll replace these terms here. CA into, sorry, NA by V into V, NA into V by V is equal to NA naught into V by V plus delta into NA naught into V by V NT naught, no? Since I have T here, I should write that as T naught, NT naught into, and here also I can't write any T, I'll write in T. Because I have T here, let me write that as T only. Okay. NT naught, and this is NA naught into V by V into XA. This term I'll cancel on. I'll just take this common and cancel it. Cancel, and I'll get an expression. NT is equal to NT naught plus delta NA naught into XA. But what do I need? I need NT by NT naught. So what I'll do, I'll divide the entire equation by NT naught. So what am I left with? NT is equal to 1 plus delta into NA naught by NT naught. NA naught by NT naught into XA. Okay. But what happens for gaseous phase reactions? No? See, this is number of moles. Moles at initial number of moles of A divided by total number of moles in the reaction mixture. But the same component, if I write for gas phase reactions, when I say variable volume reaction, now this is very important. Most gas phase reactions, most gas phase reactions are variable volume reactions. Variable volume reactions. Okay. So this Na naught by NT naught can be written as Ya. For you remember Ya is equal to Pa by P total in your thermodynamics. Pa by P total. You had written this. Okay. So the same way, Na naught by NT naught for a gaseous phase reaction. Since for the liquid phase reaction we can write like this. But the same component for gas phase reactions, what happens is 1 plus delta Ya into XA. Okay, NT. Now I'll write this as this delta into Ya as epsilon A into XA. NT is equal to 1 plus epsilon A into XA. What is this epsilon? How do I define this epsilon? Now, epsilon is defined as, I'll now define epsilon. Can you see? Change in total number of moles. Change in number of moles divided by initial number of moles. Initial number of moles taken. You see? Yes. By initial number of moles taken. Okay, or initial number of moles in the field. Okay. And now what I'll do, this V, I'll write now, V naught into Z by Z naught into T by T naught into P naught by P into 1 plus epsilon A XA. Okay. So what happens here now? If I'm carrying out the experiment in a batch mode, what do I mean carrying out the experiment? In this batch mode, what is happening? Is the pressure changing? Is the pressure and temperature changing throughout the time? No, it is not changing. It's a batch process, and in the batch process, I am maintaining the same temperature, same pressure. Only the number of moles are varying, and that is how I call that as variable volume reactions. So here, for constant batch reactors, variable volume batch system, what happens? For batch systems, the conditions are not changing. So Z is equal to Z naught, T is equal to T naught, P is equal to P naught. Only the number of moles are changing. Only the number of moles are changing. Okay, and since the number of moles are changing, the volume changes. Okay, and so for batch system, what happens? All these are equal. So this is equal to 1, this is equal to 1, and this is equal to 1. So what am I left with? V is equal to V naught into 1 plus epsilon A XA. This is very important. Okay. Yeah. Now here only I'll write the, okay, make a note of this. This is for batch system, variable batch system. This is for variable volume, variable volume batch system. Okay. Next, for a variable volume flow system. In flow system, what happens? I just had taken an example of a gas cylinder. Even in gas cylinder, what happens? Suppose this is a cylinder, when this is the pressure here changes. The pressure here is different. If I call this as P naught, it will be P1. And temperature here is T naught. And volume is changing. V is going out. The gas is going out. So V1, and here it was V naught. All these terms will be there, and along with this, N also is varying. N naught and at some conditions. Okay, so for variable volume systems, so all these terms will be there. So for a variable volume flow system, the equation for V remains the same. So I can write V for variable volume flow system will be, I have to repeat writing this equation. It is the same equation because all these conditions are varying. Z naught, Z is varying. Z, okay, compressibility factor I can retain. So temperature is varying, pressure is varying, and number of moles are varying. So I will write this as V is equal to V naught into T by T naught into P naught by P into NT by N naught. I'll write the same thing. 1 plus epsilon A XC. NT by N naught is 1 plus epsilon A XC. Okay. So this is how we summarize the formulas. Okay. Make a note of this. V for variable volume flow system. All the things are varying. Pressure, volume, temperature, and number of moles. So this is the equation. The same equation, if this is carried out for a batch process, for a batch process, temperature is not varying, pressure is not varying. So the P not equal to P, T is not equal to T. So I am left with the equation P is equal to V naught into 1 plus epsilon A XA. Okay. So this is about how we find the volume for a constant volume system and a variable volume system. Okay. Rub it and summarize the formulas. Okay, let me summarize the formulas here only for variable volume flow system. Summary of only the formulas for V naught. Okay, let me do the summary for the formulas of V naught only. I mean V only, volume only. Variable volume batch system V is equal to V naught into 1 plus epsilon A XA. V for flow system, flow system, flow system. This is the equation, and almost all gas phase reactions are variable volume reactions. Variable volume reactions. Okay. Now the same said for constant volume. Constant volume batch system, constant volume variable system. Sorry, flow system. This is V is equal to V naught here. Here FA is equal to CA into V naught, where CA is NA by V into V naught. So these are the formulas what we have. For flow systems, we will come across this FA, which is equal to CA into V naught. Okay? Yes. This is a summary. This is volume for a variable volume system, constant volume system. Okay? Yes. Let us summarize some more formulas, whatever you have learned till now. Summarize those formulas and end up the session. Okay? Make a note of this. Let me check what all formulas I have summarized for a constant volume system and then come back to a variable volume system. Okay, fine. Yes. So, for a constant volume system. So, for a constant volume system, the very first form, I'll just like to write the reaction. B by AB gives C by AC plus B by A into D. Okay. Very first formula for conversion, XA is equal to 1 minus CA by CA naught. And the second formula, here only I can write, therefore CA is equal to CA naught into 1 minus XA. Okay. And next, what I would like to finalize the formula is CA naught, CB naught into XB is equal to CA naught into XA by A. CB naught into XB by B is equal to CA naught into XA by A. This is one formula which you should remember. Okay. So how do you actually get this formula? This is again from your basic equations what you have already derived. I'll just show the derivation here and I can rub that later also. Okay. So the thing is, see, NB naught into XB. What is this? Moles of B reacted, correct? Moles of B reacted, I can call that as NB naught into XB, capital B. Okay. This is equal to what? B moles of B reacted is B by A times A reacted. Okay, B by times A reacted. So now I will take this as B by A into Na naught into XA. Is that fine? Hope you got that. Just recollect what you had done in your previous one. Okay. So now what I'll do, I will just divide this entire by V naught on both sides. What am I telling? Yeah, V naught on both sides. So what do I get this NB naught by V naught as CB naught. CB naught into XB, I'll take this B to the denominator. B is equal to CA naught into XA by A. This is what I have written here. The formula. Okay. One more formula which you should remember is, shall I write this part? You have to remember this for solving the sums. One more formula which you have to remember for this is CA naught minus CA by A is equal to CB naught minus CB by B is equal to CC minus CC naught by C, which is also equal to CD minus CD naught by B. So how do we actually get this? For this, again, you just collect the basic from the basic and go. See, XA is what? 1 minus CA by CA naught. So the CA naught into XA can be written as CA naught minus CA. Okay. I'll come to XB. XB, CB naught in the same way, CB naught into XB can be written as CB naught minus CB. Analogous to this, if I write for B, CB naught into XB will be CB naught minus CB. Okay. But what is actually CB naught into XB? CB naught into XB can be written as CA naught into XA by A. Correct. So now I'll just substitute for CB naught from this. Okay. And it is B by A into CA naught XA will be equal to CB naught minus CB, or CA naught into XA by A will be equal to CB naught into B, CB naught minus CB by B, CB naught minus CB by B. So here in this equation, CA naught into XA. So just take this equation 1 and equation 2. Okay, so what I can do for equation 1, on both sides I can divide that by A. Correct. If I do that, LHS of 1 and 2 are equal. LHS of 1 and 2 are equal. So what can I conclude? The RHS is equal. So what is in the RHS? CA naught minus CA by A will be equal to CB naught minus CB by D. Okay, so these two relations are proved. Now, how do I equate this one? Okay, so let me rub this and check how I get that relation. Right? Yes. For that, let me write the equation for CC. What is CC? How do we find CC? CC is equal to CC naught plus C by A into CA naught XA. Okay. The CA naught XA by A, no, can be written as CA naught minus CA by A. So now CC, I take the C naught this side, will be equal to, and I'll put the CA naught, this value here, because this is equal, right? So this will be equal to C by C by A times, sorry, 1 second, CA naught into C, okay, C by A into CA naught minus CA. Okay, so the CC minus CC naught by C will be equal to CA naught minus CA by A. Again, you can just observe this. See, for 1 and 3, if you observe 1 and 3, not required. Okay, I've got a relation here only. For CA naught by CA minus CA, I got CC minus C naught by C. Okay, now write that. Yeah, I have proved this. Okay. Similarly, I can prove the other one. CD minus CD naught by D. Okay. Yes. So these are the formulas for constant volume systems. Constant volume system where epsilon A will be 0. It's very important. Okay. Now let us summarize the formulas for variable volume systems. Volume systems. Okay. So first thing here is epsilon. Epsilon A is n XA at 1 minus n XA at 0 divided by n at XA equal to 0. That is changing number of moles at 100% conversion, number of moles present at 100% conversion minus number of moles at initial condition divided by inlet, total number of moles at the inlet, okay, epsilon A. And V is what? V is equal to V naught into 1 plus epsilon A XA. And CA can be written as CA is CA naught into 1 minus XA by 1 plus epsilon A XA. And XA can be written as XA is 1 minus CA by CA naught by 1 plus epsilon A into CA by CA naught. This is a very important formula. Here, okay, I just didn't write for V. No, here V is equal to V naught only. V is equal to V. Other formulas are done. V is equal to V naught, which I just forgot. Okay. Yeah. Next, what else formulas? Let me check what else formulas I have summarized. Yeah, one more thing. So this is one thing, second thing, third thing, and fourth thing. Fifth one is epsilon A XA will be equal to epsilon B XB. So how do I actually get this? I actually get this as, see, I can write for B naught, for A I write first 1 plus epsilon A XA. And for B, if I write B is equal to V naught into 1 plus epsilon B XB. What I'll now do, V minus V naught will be equal to what? 1 plus epsilon A XB. Here also V minus V naught is equal to what? 1 plus epsilon B XB. Okay. So LHS is same. Equate the RHS. If you equate the RHS, what do you get? Epsilon A XA will be equal to epsilon B XB. Okay. So this is one formula you have to remember. And I have shown you how you have got this formula. Okay. Yes. Next one. Next formula, what have I finalized? Let me check. Okay, A into epsilon A into epsilon A by CA naught is equal to B into epsilon B by CB naught. Okay. So this is one more formula which I have finalized. Okay. So how do I get this? I will get this from this relation. Okay. So you know epsilon A XA is equal to epsilon B XP. And this epsilon A XA can be written as CA naught minus CA by CA naught. Similarly, epsilon B into CB naught minus CB by CB naught. Okay. But what is actually CB? See, now I should find what is this value. They are all interrelated. You have already developed the equations. I'm just summarizing them. That's it. See, I know how do I get this in terms of A now. See, I know. Let me see. CB is equal to CB naught minus B by A, CA naught into XA. Okay. But now what I do? This CB naught minus CB will be what? CB minus CB naught will be B by A times CA naught into XA. Is that fine? CB naught minus CB, I'll write that as CA naught B by A into CA naught XA. Okay. Shall I write that and finalize? Yes. So, have I written correctly? Yeah. So what I'll now, what I had taken here is, okay. So CB naught minus CB I have found, okay. So now what I'll do, I'll substitute for this CB naught minus CB from this equation. This is equal to epsilon B into, what did I write? B by A into, I just missed a step that, what had I written? Okay, let me rewrite that. See, what was that I had written? Yeah. So this, okay, no problem. this CB naught minus CB by CB naught will be written as epsilon B into CA naught minus CA, correct? CA naught minus CA by CB naught. This is epsilon A and it is B by A times. Epsilon B into B by A times. Epsilon A into CA naught minus CA by CA naught. Okay. So what can I now write? This A I'll take to LHS. A into epsilon A is equal to B into epsilon B. A into epsilon A by CA naught is equal to B into epsilon B by CB naught. I'll just cancel these terms. Okay. Yes. Of course, all these steps what I've shown, the derivations, that is not in. We will not be doing that again and again. That is once for you to learn. But what formulas I will be summarizing now, they will be important for solving the sums. So simply, as soon as you see, okay, I tell you, remember this formula. If I just say you remember this formula, how do you remember? You should know how you have derived it. Okay. So this is about the summary of the formulas. Is it covering everything? Yes. Summary of the formulas, which is very, very important. Summary for constant volume system, V is equal to V naught and epsilon is 0. Very important. Okay. Some 1, 2, 3, 4, and 5. 5 is not required anyway. 4 formulas for constant volume systems. Okay, 4 formulas for constant volume systems. And 1, 2, 3, 4, 5, 6. 6 formulas for variable volume systems. Of course, if you remember these things, it is enough. How you have got that, I have shown you. How you have got these relations, I have shown you. How to get these relations, derivations for how to get those relations are not important for me. You have to remember these formulas, but suddenly if I just put the formula, you will be thinking, how did I just write this? Okay, so that is how I have derived all the formulas, and this is the summary of the formulas. Just remember this, practice this, and remember. Next will be problems on this. Okay, thank you. Note down first. Pause the video and note down. Okay, thank you.